Hello, so we need to be able to sketch quartic graphs. So like with cubics, firstly we're going to consider if it's a positive quartic, so it will look like that, and that would be positive x to the 4, or if it's a negative, it would instead look like this. So negative x to the 4. So positive or negative, it will have a sort of W shape or an M shape, right? And then we need to look at the type of roots we have. So firstly, if we have a single root, x minus a, just a single factor, so it's a single root, that's going to just pass through the root like this, okay? If we have a double root, it will touch the axis, it will touch the point and not go through it. So that'd be x minus a squared, that would be a double root. And then if we have a triple root, it will look like a point of inflection. So it would level off at the point and then slowly but surely go back up. And so that is x minus a cubed. That's a point of inflection, just like with cubics. And lastly, if we have a quadruple root, so x minus a to the 4, a quadruple, it will look like a double root, it will touch it, but it will be a lot more elongated. Like that, okay? So it touches the point A in the middle here, but it'll be a lot more drawn out, okay? Okay, with that in mind, we can sketch quartics. So firstly, we need to sketch y is x of x plus 1 squared, x plus 2. So firstly, it's going to be positive x to the 4 if we visualize expanding out the highest powers of x. So it's going to have a sort of W shape, right? And with that in mind, we can sketch a graph. Our roots are x is 0. We've got a double root at x is minus 1. And a single root at minus 2. So it will pass through minus 2. It will touch minus 1. Create a turning point. And then another turning point, and then it shoots back up. Okay. And then the y-intercept here, well, the y-intercept, that's going to be when x is 0. Then y is going to be, well, 0, right? It's going to pass through the origin. Okay. There we are. For part B, we need to sketch this. So firstly, recognise it's going to be a negative quartic, because 2x cubed, that'd be x cubed, x to the 4, but we have a negative outside, so it'd be a negative x to the 4, so it'd be a negative cubic, so it's going to have a sort of M shape, okay? And so then if we sketch our quartic, well, firstly look at the roots. This is 2x minus 1 cubed, that would be x to the half, but that's going to be a triple root. And then we have x is minus 5, that would be all the way over here somewhere. And so as it will pass through minus 5 as it's a single root. And then it will come down to reach the second root. And then because it's a point of inflection, it will level off. And then it will drop back down. And so that's my shape. And so that's lastly the y-intercept here. That will be when x is 0. Then y is going to be minus 1 cubed of 5. And so that would be positive 5 there. Okay, so the 5 there. Cool. And for part C, we need to sketch x plus 4 to the 4. So that's just that's going to be a positive quartic, right? So it's going to have a sort of perhaps W shape like this. And it's a quadruple root, quadruple to the 4. So it's going to be really elongated when it touches it, and then it will shoot back up like this, okay? And so then lastly, the y-intercept then, if we were to continue the graph on, eventually it cross the y-axis here. So the y-intercept when x is 0, then y is going to be 4 to the 4. That is going to be 256. Okay? And also we need to be able to go in reverse and, given a quartic graph, work out the quartic equation. Okay, so here, well, we have two roots at minus 1 and 3. So my factors are x plus 1, x minus 3. Well, the problem here, you might notice, that will only get me a quadratic. Well, we have to look at the type of roots we have. These both touch the axis. So they're both double roots. So both are squared factors, and that get me a Quartic. Cool. But that wouldn't be. I then need to add on a numerical factor a, because if I was to solve this equal to 0, I could just divide by a, and then I'll get the same factors. So I need to account for that missing possible factor a. So to find a, well, I also know the y-intercept is at 3. So the y-intercept 3 means 0, 3. So if I substitute that in, that means 3 for y. It's going to be a lots of 1 squared minus 3 squared if x is 0. So 3 is going to be 9a. Therefore, a is a third. And so my Quartic is y is a third of x plus 1 squared x minus 3 squared. And so I could expand these brackets as I've done here in this line of working to get back an actual Quartic equation that's not factorised. And so I can read off the coefficients as a is a third, b is minus 4 thirds, c is minus 2 thirds, d is 4, and e is 3 as my coefficients of all the powers of x there.